Hello, algebra students. Mr. Lawrence here, and this is your second chance review video. The second one, this will be all about the nth term. Hopefully you're catching on how this works. Remember, if the first differences are the same, we're going to take that first difference, divide it by 1, which is trivial, nothing happens, and we're going to multiply it by n, and it'll be n to the first power. It's going to be a linear expression. If the second differences are the same, we're going to have a quadratic expression. N is going to be squared, but it's going to be multiplied by, half of whatever the second difference is. The second difference that's repeating, okay? The third difference, the same, makes it cubic, and that'll be n cubed, n to the third power, and to get the number in front of n, you're going to divide by 6, the third differences. All right, if the differences are being multiplied, it's going to be exponential. All right, so you should have those notes down somewhere. If you didn't get them, this last time we reviewed, you have them from a previous time, email me if you don't. All right, so I'm going to go find my first differences. And it looks like I got plus 6, and then plus 18, and I just noticed something. I noticed that 6 times 3 is 18. Now, I'm not guaranteed to have an exponential pattern at the moment. 36, I believe, and then plus 60. It looks like my pattern of times 3 is not holding. So this is probably not going to be an exponential function. Now, maybe the second differences will reveal it's exponential. I don't know. But needless to say, I'm going to go find these second differences. And so it looks like we got plus 12. It's not linear. Let's see what the third differences say. Oh, look at that. Plus 6 and plus 6. This is a cubic pattern. So this is going to be n to the third power. Right? N to the third power. Now, the number here is going to be 1. Why is that? Because I'm going to divide this by 6. 6 divided by 6 is 1. So now I do my comparison line. Okay? And so I'm going to 3 to the third power, showing this baby step here, 4 to the third power, and 5 to the third, 8, and that'll be 1. And I'm going to ask myself, how do I turn the red ones into the black ones? How do I change the 1 into a 0? Well, I subtract 1. How do I change the 8 into the 6? I subtract 2. 27 to 24. I subtract 3. Oh, I know what I'm going to do. If I subtract 1 on the first one, 2 on the second one, 3 on the third one, what am I going to subtract on the 85th one? 85. What am I going to subtract on the fireman one? Fireman. Well, on the nth one, I'm going to subtract n. The pattern is n cubed minus n. Now, some of you have made up your own rule, and your own rule is wrong. Some of you are saying that, oh, you subtract n when they don't match. No, it's a pattern. On the first one, I subtracted 1. The second one, I subtracted 2. The third one, I subtracted 3. So on the nth one, I'll subtract n. I'm just being consistent. All right, now, in a second, I'd like you to pause the video because I have a problem here for you to try. You go ahead and try it. Pause the video. See if you can figure it out. Fourth term, fifth term, and of course, nth term. So I'm going to go looking for my first differences. And so it looks like I'm going to add 2. And then I'm going to add 4. And then I'm going to add 8. Ooh, I see what's happening. And then I'm going to add 16. Can you see what's happening? The differences are being multiplied. It's times 2, times 2, times 2. Yep, this is exponential. So it's going to be this number here to the power of n. And I'll do my comparison line. Be careful, many of you are doing the order of operations incorrectly, or you're not thinking about these right. This is 2 to the first. This one will be 2 to the 5th. So 2 to the first is 2, 4, 8, 16, and 32. And how do I turn the blue ones into the black ones? The comparison line into the original line, not the other way around. I think I'm subtracting 4 every time. So my nth term is going to be 2 to the power of n minus 4. All right. So there's one for you to do. I'd like you to pause the video. When you're done, go ahead and unpause it, and you can see what my nth term was. There it is, 2 to the nth power plus 5. All right, next problem. Let me label it. Let's see, 1, 2, 3, 4, 5, and n. Okay, and the first differences are plus 8, plus 8, plus 8. Oh my goodness. I know this is linear. So I'm going to take that first difference, divide by 1, it's going to be 8, and multiply it by n. And now I'm ready to do my comparison line. Should have changed colors. 8 times 2, and then 8 times 3, and then 8 times 4, and then 8 times 5. So we have 8, 16, 24, 32, and 40. How do I turn the red ones into the black ones? The comparison line into the original line. Yeah, look at that. It's minus 6 every time. Therefore, the nth pattern, or the nth term, is going to be 8n minus 6. Okay? One more time. There's a problem for you to do. There it is. Go ahead and pause the video, and when you are ready, go ahead and unpause, because here comes my solution. My nth term is negative 3n plus 8. Okay, one more to do here, one more to do. So, this is the first term, the second term, the third term, fourth term, the fifth term, and then the nth term, right? Okay, and go to find the first differences. It looks like we're going to add 20. No, add 30. Then we're going to add 50. And then we're going to add 70. And then we're going to add 90. And then the second differences are plus 20, plus 20, plus 20. The second differences all match. This must be quadratic. So I know it's going to be n squared, but how many n squared will it be? Well, I'm going to take the second difference and divide by 2, which will give me 10n squared. Now this is important to get the order of operations correctly here. So I get my blanks for my comparison line. Yikes, my airliner is out of control. All right, so I'm going to do 10 times 1 squared. Then we do 10 times 2 squared. And this one here, since we're kind of getting cramped, it's going to be 10 times 3 squared. 10 times 4 squared. And finally 10 times 5 squared. Now it is very, very important that you do your exponent first. I'm going to multiply 1 times 1, do 1 squared, and then multiply by 10. This is not 100 because exponents come before multiplication in the order of operations. Here I'm going to do 2 squared, which is 4, times 10 is 40. Here I'm going to do 9 times 10 is 90. This will be 16 times 10, which is subtract 5 every single time. So it's 10n squared minus 5. All right, I'll bet you know what's coming next. There it is, your turn. Go ahead and get the nth term for me. And then when you're ready, you can scroll. I'll scroll down a little bit more. Okay, so I'm getting ready to scroll. If you haven't done it, please do. And here is my nth term. Now, by the way, some of you were really confused, like how to find the 25th term or something. To find the 25th term of this expression, the one you just did, I'm going to substitute 25 in for n squared, or in for n, excuse me. That's all I do. I just substitute in. And I use the order of operations, so I'm going to have 3 times 625, that's what 25 squared is, plus 1. 3 times that is going to be 5, 7, I believe that's right, 1,875. Let me just check that really quick. Oops. 625. So for multiplying, 5, 7, and 18. Yeah, that's right. Okay, and then we're going to add the 1. So it's 1,876 That is the nth term. All right, so that's it for the video. I wish you well. If you have a question, please email me. Mr. Lawrence signing off. Have a good night, everybody.